Okay, in this video we're talking about the periodic table groups or families. Sometimes you'll hear them called that. I'm talking about the same thing basically. We're going to start out looking at some of the families that include metals, and so we've talked about the classifications. Don't get those confused with the families. So classification means that some of them are metals, we have non-metals, and then we have the metalloids. And so you can see on this periodic table, it actually labels some of those other metals and metalloids and non-metals in some of these mixed groups that we're going to talk about today. So the first groups that we're going to talk about are the ones that are classified as metals. Metals are typically shiny, not always. Metals are usually malleable, so they can be hammered or rolled into sheets. They are also ductile, can be drawn into wires. So things like copper or aluminum, if you have really old wiring in your house, you may be familiar with that. But those are ductile. That's a trait of metals. They can be drawn into wires. Except for hydrogen here at the top. Groups 1 through 12 are all going to contain all metals. So again, except for hydrogen here at the very top. The first group we're going to talk about are the alkali metals. This is group 1. These metals are going to be softer than most metals. So then especially with what you're familiar with. So you're kind of familiar with alloys and aluminum, hard solid metals. These are kind of like a stick of butter. In fact, like sodium and potassium in its pure form, you can actually cut through those with like a butter knife. So that's how soft they are. So you kind of got to change your definition of what a metal is. So these are the alkali metals. So spell it like this, alkali metals. And this is group 1. This is the most reactive group of all the metals. It has one valence electron, and so it just needs to get rid of that one electron in order to have a complete outer energy level. And I told you guys, the closer they are to completing their outermost energy level, the more reactive they're going to be. So group 1, the alkali metals, are very reactive. They're so reactive that they are not found in nature by themselves. So they're usually going to be combined with some other element. In a lab, though, they can separate them out and actually create like pure potassium, but they would only do that in a lab. It's not going to be found in nature that way. The next group is the alkaline earth metals. So the alkaline earth metals, again, kind of have those traits of being malleable, ductile. They have 2 valence electrons. So this group right here, this is the alkaline earth metals. And so we would spell that like this. Alkaline earth metals. I'm not going to write metals at the end, but you get the spelling there. So the alkaline earth metals, this is group 2. Again, they are very reactive. So again, like group number 1, the alkali metals, they're not found naturally in their elemental form. The next group is the the next family is the transition metals, and so we have 3 through 12 are our transition metals here. It gets the name transition metals because they're considered to be in transition between the main groups. So I told you guys before, the main groups are groups 1, 2, and 13 through 18. So these are in transition, or in between those. They're less reactive than the first 2 groups, which means they can be found in nature with uncombined elements here. So you can find a lot of gold, like you can find gold nuggets in the ground because they don't have to be combined with any other element because they're less reactive. These are probably ones that you're more familiar with in the transition metals, things like silver or copper or nickel, iron or titanium. Those sort of things you're kind of familiar with because these are not always found mixed with other elements. They can be found by themselves. The next groups are the inner transition metals, and those are the lanthanides down here and the actinides. These are the inner transition metals. Um, they get their names from the first element in each of the rows. So lanthanides get their name from lanthium because that's the first element, and the actinides get their name from actinium. The actinides, which are the elements with the bigger number of protons and electrons, so those are going to be more rare and don't necessarily exist in nature. You can see on our periodic table in the classroom that some of them actually have white lettering. That means that they're synthetic, so they're only created in the lab. They're not found in nature. One you might be familiar with is uranium in that case. Okay, so let's erase this and go to the next group. We're going to start talking about some of the groups that are just nonmetals, and then we'll get into the mixed groups here. But the nonmetals are not malleable or ductile, so they can't be hammered into sheets or drawn into wires. Most of the time, they're going to be like going to be brittle or a powdery substance, and they're poor conductors of heat and electricity. Nonmetals can be found in groups 14 through 18 here. That doesn't mean that all the elements in those groups are nonmetals. Some of these are mixed groups, so they have nonmetals, metalloids, and metals in them. The first one we're going to talk about of the nonmetal group, let's talk about hydrogen here. Hydrogen's not really in a group. It's above the alkali metals because it has one valence electrons, just like the rest of these. So it is going to be very reactive. It can react with other nonmetals and create a covalent bond. So if it bonds with oxygen, it actually creates H2O, water, which is the most abundant form. That's where we find most of our hydrogen on planet Earth here. You can also create an ionic bond with some of these other elements below it. So like it will often bond with the alkali metals or the alkaline earth metals to create different substances as well. Another group that contains only nonmetals is the halogen group, group 17. So these are the halogens, and they include fluorine, chlorine, bromine, iodine, and astatine. And group 17, this is the most reactive of the nonmetal groups. It has 7 valence electrons. In fact, fluorine is the most reactive nonmetal on the periodic table. A lot of times these will form diatomic molecules, which means that there are they have 2 of the same element there. So it would be 2 fluorine atoms combining or 2 chlorine atoms combining. And as a gas, chlorine is actually a greenish yellow color, bromine is actually a reddish orange, and iodine is actually a violet color. So whenever they create those diatomic molecules and become a gas, that's the colors of those. The next group of non-metals is the noble gases. So this green group here, those are the noble gases. These are the least reactive. This is the least reactive group on the entire periodic table, and of the nonmetals. So the noble gases, they're extremely stable. They have all their valence electrons with 8 valence electrons, except for helium has 2, but it still has a complete outermost energy level. Because they are stable and don't react with other elements, they can be fairly useful, like transporting like potassium or sodium. They used to pump some of these gases into the container with these potassium or sodium so they don't react with anything, don't react with the air. Helium is much lighter than air, so it does float. It's used in balloons and blimps, and it's less reactive than hydrogen, so it makes it a lot safer to use as well. So that is the noble gases. One other thing, with the neon, whenever you guys hear about like neon lights, that doesn't always mean that neon gas is the one used in those lights. Sometimes it's oxygen, nitrogen. Each of these different gases, whenever you pump a current through them, create a different color. So depending on what color it is, those neon lights kind of determines what gas you're going to use. Okay, the mixed groups 13 through 16. Some of these, so groups 13 is the boron group. It contains one metalloid and the rest are all metals. So this is the boron group, and you guys can label those as you go. Then aluminum has a lot of different uses. It's actually a strong metal for its density. It's actually a light and strong metal. Has a lot of uses that you're probably familiar with, like aluminum foil or covering the outside of airplanes with aluminum. Makes them light but still fairly strong. The next group is the carbon group. It contains carbon, we have silicon, germanium, tin, and lead. All of those you're probably fairly familiar with. Carbon is a fairly important element. It's used to make up our bodies, plants, coal, oil, natural gas, you name it, probably has some form of carbon in it. Plants actually use CO2, which we breathe out in the process of photosynthesis. Graphite and diamonds are actually made out of pure carbon. It just has to do with, they're actually called different allotropes of carbon. It's just how the structure, how they put them together that determines whether it's a diamond or graphite. Graphite is what you use in your pencils now. You don't use lead anymore. The nitrogen group 15, contains two metals, two metalloids, and one metal. Then let's just kind of skip ahead here to the oxygen group. Is group 16, contains sulfur, selenium, tellurium, and polonium. Oxygen, another important element. We use that in some of our functions in our body. Our muscles use oxygen to allow them to actually move around. That's why you get tired whenever you do a lot of physical activity. Your muscles are oxygen deprived and you breathe harder, things like that, trying to get more oxygen into your body. Okay, so if you guys need the full version of the notes to take notes on, there's going to be a link above the video, so you guys can check that out. Make sure that you guys are studying this. The test is basically going to be questions about these groups, so make sure you're looking at those. And I'll see you guys in class. Good luck.